California's weather and climate are products of proximity. Bordered by the Pacific Ocean and the Sierra Nevada mountains, we take what Mother Nature dishes out. Sometimes it's a bit too much. Other times, barely enough. Understanding which storms will crash and burn when they hit the coast and which could fill our reservoirs is a hard job. Even experienced forecasters can be surprised by how much or how little rain we end up with.
But the science and savvy regarding West Coast storms are improving. Researchers are flying into the heart of Pacific Ocean rain and snowmakers in a study called CalWater to try to determine which weather systems are capable of flooding or could just get us out of the drought.
Well, this really helps us in understanding the mechanics of these storm systems better, which improves our ability to forecast and warn and develop response capabilities built around this. We don't have to wait until the rain is falling out of the sky and into our rain gauges to figure out what's going on.
The CalWater fleet is comprised of 4 research aircraft and a ship, taking to the seas simultaneously to measure the strength and characteristics of incoming storms. But not just any storms, atmospheric rivers. Call them ARs for short. They're air currents that carry huge amounts of water vapor from the tropics to the west coast. On average, each can transport as much water as 20 Mississippi rivers.
Well, it's exciting. I mean, to have this many types of observing assets available to us as researchers, it's phenomenal, because now we can place planes in the atmospheric river, we can have planes flying above the atmospheric river, and we can have the ship right underneath the atmospheric river.
The California Department of Water Resources is a research partner on this study, but the bulk of the work is led by UC San Diego's Scripps Institution of Oceanography. Technical and flight support comes from NOAA, NASA, the Department of Energy, and the National Science Foundation, all working toward improving West Coast forecasting, a region of the country that has not, to date, gotten its share of attention. In California, we used to call them the Pineapple Express. Now we know the same pattern takes place all over the globe. Half the state's water supply comes from atmospheric rivers, often in powerful downpours that can hit in rapid succession.
Let's say fast forward a week and another one hits, and fast forward another week and another one hits, and it's twice as strong as either of these first two. Then we've got the potential for a type of storm that could cause really catastrophic flooding. And it's really the story of landfalling atmospheric rivers that are really strong and stall out and actually create the kind of flooding in Sacramento that was seen with hurricanes in the East Coast, like Katrina in New Orleans and Sandy in New York.
On the flip side, we gradually slide into drought when we get fewer and fewer atmospheric rivers, and don't get out until we get some more. 7 of the last 12 droughts ended in ARs. CalWater's mission is to understand the forces that enhance or diminish their strength.
Quicker and more accurate flood safety warnings, better drought prediction, and the role of small particles in cloud formation are all aided by knowing what goes on offshore.
Kim Prather studies the small particles that give cloud drops a place to start. Little bits of dust and soot play a surprising role, not just in getting droplets to form, but in how much rain or snow actually falls. One atmospheric river that looks like another on satellite could yield 40% less precipitation if the source of the seed particles is man-made.
One of the things we hope to really get out of this study is to study enough storms where we can isolate storms that are affected mostly by Mother Nature versus those that also have the human influence. If we can do that enough times, maybe we can take a page from, Mother Nature's book and really start to think about how does that seeding work.
Add on the risks posed by climate change, and you've targeted a real need for advanced research. How will this help scientists with future projections?
The major difference in the models is how they handle atmospheric rivers. The dry ones don't have enough, the wet ones have too many. We don't know what truth is until we go out and measure them. So that's a big part of what we're doing with the experiment, is we're collecting the first ever comprehensive data set on the strength and structure of ARs offshore to compare with these climate models and try to see which ones might be more accurate.
Now that the unique needs of the western U.S. are being investigated, the day may come where we can know an AR's impact up to a week in advance. This will make California better prepared for the many critical water supply and flooding problems tied to atmospheric rivers, achieving the goals of those leading the CalWater mission. This is Alyssa Lin with the California Department of Water Resources.